So I'm Paul. I am one of the co-founders of Unison Computing. We are a small public benefit corp. We're on a mission to make software a lot simpler to create and more accessible to more people, and also advance the state of the art in what's possible. We have two big efforts that we've been working on. One is the Unison programming language, which some of y'all may have heard of. That is open source, and the other is the Unison Cloud Platform. This is our first product. It's going to be shipping soon. I'm going to be talking about both these things today, but I'm also going to try to make the talk relevant to people working in other language ecosystems. So what am I going to be showing? A new approach to building microservice backends, which is a lot simpler than what folks are doing these days. And what are folks doing these days? They are building things like this. And what even is this? Okay, in the center here is this is a microservices graph. These are sometimes called Death Star diagrams, which I think is hilarious. Each point on this circle represents a different service. Lines between points represents calls between services. And even if you don't have a gajillion microservices like this, even if you just have a handful or a dozen, building and operating a contraption like this is pretty difficult. So each of your services has to be packaged up, deployed. All of those service call boundaries, you generally have some layer of parsing and serialization, converting to blobs of JSON or protobuf or whatever else. And to try to kind of make this easier, there is this deluge of different cloud native technologies. That's all this stuff in the background here that you're supposed to kind of use in some combination to assemble a system like this. But it's complicated, and it's complicated in kind of a strange way too. So a lot of the work you end up doing is not programming. So let's compare. If I have, say, a list of things in memory on one computer and I want to sort it, how do I do that? I call a function in my programming language. And that experience is pretty great. I call that function with the same uniform syntax as I call any other function. I often have a type checker, make sure I've called the function correctly. I can introduce new functions, new abstractions, and it's basically sunshine and rainbows. Okay, but then in this world of building microservice backends, you have these other kinds of things that you have to do. Like for instance, how do I connect an auto-scaling group to my managed Kubernetes cluster? And how do you do that? Well, you don't just call a function. It's some bullshit, basically. Let's see here. Step one, download the cluster autoscaler YAML file using this curl command. Okay, we're kind of off to a bad start here. Open up the YAML file. Find and replace angle bracket your cluster name with your cluster name. Also consider, and it's just like, what even is this? It is just strange. So why is there this distinction between sort of the normal experience of programming where things are logical and make sense and fit together and are cohesive and consistent, and this just kind of garbage fire of random gobbledygook that you have to put together to build things in the cloud? So that's a question. Why does that even exist? I'm going to come back to that, but let's put aside the negativity for a minute here and try to think positive. And what is the dream? So I think the dream has three parts. So part one, deployment should be dead simple. You should be able to deploy services with a single function call in your programming language. I don't want to have to package things up and build and ship around these multi-gigabyte containers. I just want to focus on the logic of my service, and then I want to call a function and say, hey, make it so in the cloud. And I just want it to work. Okay, so that's part one of the dream. Part two is service calls should be super easy as well. I would like to be able to make service calls with a single line of code. I don't want to have to convert things to and from blobs of JSON or protobuf or whatever else. I also want my service calls to be typed. So I want the type checker to tell me, oh, you passed the wrong kind of argument to this service. I basically want it to be as easy as making a local function call. Now that said, I do want the type checker to keep track of where these remote calls are happening, because that's kind of an important thing to be aware of. But I don't want a bunch of busy work on either side of that service call boundary. That is just an annoying waste of time. Okay, and then the third part of the dream is I would love the same experience for accessing, the database, the storage layer. I would like that to basically be as easy as accessing in-memory data structures. Okay, so all of these things are possible. I'm going to show you a demo, actually a few demos. But before getting to the demos, I want to just get into how do we actually do it. So let's take each of these in turn. We're going to start with the most difficult one. How do we deploy services with a function call in our programming language? So zooming in on this a little bit. So here is our deployment function. We're calling the deploy function. We're passing it my service. Now, thinking this through a bit, so my service, it could reference anything in the programming language, right? It could close over some static data. It could reference other functions. And so table stakes for being able to do deployment at runtime like this is all things in the language need to be serializable. Otherwise, we don't even have a way of transferring the bits of my service to wherever it needs to be deployed to. Okay, so that's the first requirement. But that's not quite enough, because my service, it can have dependencies, right? It could call other functions. And so the second requirement is we need to be able to, at runtime, enumerate the dependencies of my service. Because it's not good enough to just deploy my service, we also need to make sure all its dependencies get deployed as well. Okay, so that's the second requirement. But that's not quite enough either, because if you sort of think about this, well, it seems possible that wherever we're deploying my service to could have a conflicting set of dependencies. And so we need some story for just completely eliminating dependency conflicts as a possibility. But anyway, seems like kind of a tall order, but if we can do all three of these things, then we are good to go and we can deploy services with a function call. Okay, so how do we do it? So zooming in a bit further here, suppose my service, it does some stuff and then it calls factorial of 9. What is factorial? It's just a function I defined here. Factorial of n is the product of the numbers 1 through n. So here's the key question. How do we actually encode the reference to factorial here? So we need to somehow send the code for my service to wherever we're deploying to, and how do we encode the reference to functions like factorial? And so one thought, that comes to mind is like, oh, well, let's just try sending the name factorial and just kind of hope for the best. And this doesn't work because this is basically assuming that the name factorial is going to always mean the same thing everywhere. No destination that you're deploying to is going to have a conflicting idea of what factorial should mean. And that just kind of doesn't work. So what does work? So here is the big idea. This is the Unison programming language is based around this entire idea, and it's kind of the key thing that gives us the superpowers I'm going to be showing. So this is super important slide. So the idea is factorial is going to have a hash, A82J. Now it's also going to have a name, for showing the code to a human, but it's going to have a hash, and that hash is in turn going to be based on the hash of the product function, the range function, and all of the actual structure of the factorial function. So that hash is going to uniquely identify the exact version of factorial we're talking about, and it's also going to pin down the exact version of all its dependencies. By the way, in practice, these hashes are going to be long cryptographic hashes. We don't have to worry about collisions, but I'm trying to fit it on a slide. So anyway, with this idea, we now have a nice way of doing deployment. So what we can do when we're serializing my service is we're actually going to send, instead of the name factorial, we're going to send that hash, A82J. And wherever we're deploying to, it can have a cache that's keyed by those hashes. It can say, hey, I already know about all those hashes, I'm good to go. Or it can say, oh, I'm missing some of those hashes, can you just sync them on the fly? And so we just have this very simple little negotiation that we can do as part of deployment to just make sure the code and all its dependencies get synced. And that's the gist of it. So using this idea, we can now do deployment with a single function call. So this is some Unison syntax. I'm not going to talk too much about Unison language syntax here, but just showing that we're calling the deploy HTTP function, and one of the, we're passing it the logic of our service as just a regular function argument, and that is going to just be deployed and made available in the cloud, just like that with a function call. Okay, so sounds pretty magical, right? Yes? Okay, let's see if it actually works. Does it work? Okay, so let's see how legible. Okay. Great. So on the left here, I have just VS Code running. On the right, I have Unison watching for changes to this file. Unison also acts as an LSP server, gives us things like autocomplete, real-time error highlighting, and so forth. The other thing it does is when I save the file, it's going to parse and type check it. Also prints out the result of these watch expressions, these lines starting with greater than. Okay, here is our hello world service. I made it slightly more interesting, so I'm actually capturing a URL parameter here. And I'm doing some logging, so it's enterprise ready. And here is the deployment function here. I'm calling deploy. I'll say more about that in a second, but let's actually go ahead and try running it. And what this is actually going to be doing, it's going to be packaging up that code. Oh my gosh. Not connected to the internet. Great. Oh my gosh. Yeah. Okay. It's funny, I was literally just outside connected to the Wi-Fi, but
Yeah, you have to change the password. 1547 Lakeside.
okay. So when you try to deploy to the cloud and you're not connected to the internet, that does not work. Just pro tip. Okay, let's try that again, once more with feeling. Okay, cool. So that actually worked this time. So it's serialized the service and deployed it to the cloud, and also uploaded all its dependencies and exposed that as an HTTP endpoint. Which let's just go ahead and hit this. And we can say, I don't know, hello, Scale by the Bay. We can say, hello, Paul. Okay, so it's working. You might be wondering, where did those all-important log messages go? And here is where they went. So if you go to app.unison.cloud, you can see, the calls to the service. You can also stream your log messages locally to your local console if you prefer. Okay, so one thing I was going to show before we keep going. So when you deploy a service, you actually get back a value. You get back a service hash. So that's what that portion of the URL is, that long sort of GUID-looking thing. Anytime you change the service, that hash is going to change. So it's also sometimes handy to have services have names that have a stable identifier. And so this line here, you can see we're assigning this service name hello to that hash. So service names can basically point to service hashes. And this is handy for things like testing. You can deploy a service, test it by hitting the hash, and then assuming it test pass, you can promote to production by assigning a service name to point to that hash. So we could actually hit the same service by name as well as by hash. So here I'm hitting it by the name, service name, hello. Okay, great. So, success. Part one of the dream accomplished. Let's move on to the next part of the dream, which is making service calls super easy. So just kind of zooming in on this a little bit, imagine this is some sort of hypothetical syntax for calling a service. What do we need to do to make this happen? Well, we're certainly going to need to be able to serialize the arguments, and we're also going to need to serialize the results that are coming back from the service. Moreover, we need to be able to do that without dependency conflicts because the caller and the callee may be sort of on different locations, have a different environment. And so, we need kind of a way of doing that, but we basically already figured that out for the case of doing service deployment, and we're just going to employ the exact same trick. So here is how that shakes out in Unison. Okay, so there is a function now, deploy. It takes a function from A to B. It returns a service hash AB. So service hashes are actually typed, so this is very important. When you call a service hash AB, you give it an A and you get back a B. You can also call a service name as well if you want to refer to a service by its service name instead of by its service hash. Other thing I was just going to point out, so your services can have effects. So Unison has an effect system. It keeps track of where you're doing these service calls. Doesn't make you use a completely different syntax, just sort of keeps track of them in the types, and that's sort of useful information to be aware of when you're programming. So our album service, let's suppose this is a service that you give it a song, it gives you a list of albums that song appears on, and that's going to have a type that reflects that. And here's what like a service call would look like. And by the way, so my daughter is a huge fan of Taylor Swift, and maybe one day she will watch this talk and think it's funny that I use this as an example. But Cruel Summer is an amazing track, I'm just saying. Okay, but moving on, let's see a demo of this actually working. Okay. So we're going to be deploying multiple microservices that are all talking to each other now. So I'll sort of just breeze through this code. Here's the declaration of the song type, the album type, a little encoder to JSON of the album, because we're going to be returning a list of albums as JSON. Here is the logic of our service. It's kind of silly. We only know about this one song, Cruel Summer, and all the other songs we're just going to kind of give up. But the deploy, this is just like on the slides, deploy, it does return a typed service hash. And then here is the main HTTP edge service, which just calls that album service. And it really is just that simple. It's one line of code. We don't do any manual sort of encoding or decoding of the arguments or the results. We just call the service, and it works. So, or hopefully it will work. So let's try actually deploying this. So we're going to run music app.deploy. So this is now going to be deploying these two different microservices, one for the album service and one for the HTTP sort of edge service. So let's go ahead and hit the HTTP service. I don't know how legible that is, but anyway, we look up Cruel Summer and we can see that it does indeed appear on the album Lover by Taylor Swift. Amazing. So it's happening. We have multiple services being deployed just like that, and they're communicating, and it's super easy. Okay. We're on a roll. We're 2 for 2 here. Let's look at the third part of the dream. Oh, one thing I was going to point out. So the nice thing about this approach is if you ever want to change how your service graph is factored, how the functionality is broken up into different services, that's actually a nice experience because you actually have the type checker to guide the process. So it's a lot like kind of refactoring just sort of local in-memory code, where you also have the type checker to help you along. You don't have a pile of boilerplate and encoding and decoding, converting to JSON that you have to shuffle around while you're doing this. You just kind of focus on the logic of what you're doing, and it's pretty great. In fact, while I was implementing this extremely advanced application that I just showed you, I actually had a type error where I was like passing the wrong kind of thing to the service, and I got just a regular type error, and I fixed it in five seconds, and it was good. So, okay, let's move on to the last part of the dream, which is a nicer approach to talking to durable storage. Now, that said, Unison can still talk to external databases and so forth. That's same as any other programming language, but we wanted to have a nice Unison native way of accessing storage. So, I think you can maybe guess where this is going about how we're going to solve this problem, and it's literally, we're going to use the same trick that we used before. So, serializing a service when you're doing a deployment, it's the same kind of thing if you are serializing values of your language to the storage layer. And so we're going to just apply the exact same tricks that we've done before. Here's an example of how that shakes out in terms of the API. So you can declare these typed tables. The tables can have any key type, any value type. Here we have one mapping songs to lists of albums. Here's just a little bit of example code populating a row of that table. And then within your services, you can literally just do lookups in these tables as easily as if the table, it was just sort of in-memory data structures. And this all works, so I'm going to show you a quick demo of this and also point out a few interesting things about this. Okay. So scrolling down a bit, so this is Music App 2. I've declared a table mapping songs to lists of albums. I actually have a little batch job here to populate that table with some rows. I'm actually super overkill, but I'm massively parallel inserting all 4 of those rows at once with this par map call. Also just showing off that services, the storage layer supports transactions, so you can update multiple rows of multiple tables in a single transaction. And yeah, and then here's just the rest of the logic, which looks pretty much the same as before. So I'm going to go ahead and deploy this. And yeah, this is going to populate that table. It's going to deploy those services and expose HTTP endpoint. So if I go ahead and look up this song Shadow Journal, we can see that does indeed appear on the album The Blue Notebooks by Max Richter, which is one of my an album I quite like. And yeah, it's all working, and yeah, we've done it. Mission accomplished, right? Okay, so I think that was it for the demos. So let's jump back to the slides. Okay, so in conclusion, hash identifying code, it really does unlock all the things. It's sort of like a superpower. We've been building Unison over a number of years, and it feels almost like we're building on alien technology. This idea, it just makes so many other things a lot simpler, and it's been a blast to work on this. I want to come back to this question that I started with at the beginning, which is why building systems the current way is so complicated. So here's the reason. It's that our programming languages are just way too narrow in what they can talk about well. So what we think of today as a program is generally a description of what a single OS process on one machine is doing. And that is a tiny little box. And the experience when you're within that box is pretty nice, but at the boundaries of that box, you have all this sort of boilerplate code to convert, to and from different formats. And then there's this larger question of how do you organize, you have a system like this, which is, hundreds or thousands or hundreds of thousands of these different OS processes spread across lots of computers, and they all need to be communicating and, coordinating to do a thing. And it's like our programming languages there's a lot of information here that needs to be specified to build a system like this, and our programming languages can't do it because they're trapped in this box. And so that's what results in this huge mess, where we have all this information that needs to be specified, right? And our programming languages can't do it. So what have we come up with instead? We've come up with, the cluster autoscaler YAML file, and just kind of this mess of just random ad hoc stuff that's been kind of thrown into the mix with no thought of compositionality or it being consistent or cohesive, and it's just a huge mess, and this is not the future. So the future is programming languages that can talk about entire systems like this, and that's what we have been building with Unison, and it's just been amazing seeing that it's actually working out and we can actually build systems in this way, and it's just so much nicer than kind of the status quo. Okay, so if you think that this stuff sounds cool, a couple links here. So one is just this first link. So the Unison Cloud is currently in limited beta. We're looking for folks to help us test it out and tell us what they think, report bugs, things like that, before we make it widely available. So if you'd like to join that program, you can check out this first link. Also, we're going to have just a casual get-together tomorrow night. There's some details about that also at that first link. So we'd love to just chat with folks more about the future of computing and making computing simpler and that sort of thing. And unisonlang.org is the homepage for the open source Unison programming language, and you can learn more about the language itself there. And lastly, just really want to thank all the contributors to Unison over the years. This has been the work of many people, and thanks for being a part of this. And that's it. Thank you.
We have time for a couple of questions.
So I think the last time we talked, you hadn't actually gotten the data stuff in yet, and so I'm really excited to see that. But where do you see yourself taking Unison next? What's on the roadmap over the next 6 months or a year?
That's a good question. We have a lot of thoughts on that. I think sort of probably the most immediate thing is we want to just get this in people's hands, playing with it, and kind of see what they say about what they would like to see. But yeah, I guess we do have there's a lot of directions we can take it, and so it's kind of just a question of like, what are people most interested in? So, sorry, kind of a non-answer, but definitely come talk to us after.
What does it look like to have your Unison code interact with code that's written in some other language?
Yeah. So if you are talking to code that's written in another language, so it's really not that different than sort of other programming languages in the sense that, like you could write a Unison service that is an HTTP service and can be talked to from any other programming language. And, the same goes in the other direction, where if you have some other service that's exposed over HTTP or whatever else, then you can certainly talk to that from Unison. Obviously you don't get as many of the benefits because it's, you have that layer of annoying kind of stuff when you're talking, across languages. But you can do it and it basically works the same as other languages.
One more question.
So in the last demo for the database table, there was no notion of a database engine, or so is it that what's actually happening behind the scenes, I guess, or how does Unison interpret this command?
Like how does basically how does the storage layer work?
Right.
Or-
Is it a Unison specific storage layer that you're employing here, or?
Yeah, so that stuff, the storage stuff that I showed was Unison Cloud's storage layer. So that's like a sort of fully managed, super scalable cloud storage that we manage in our platform.
And can Unison be made compatible, I guess, with other database engines?
Yeah, so if you want to talk to other data stores, that you would do that pretty much the same way as you would in other languages. There's nothing really Unison specific about that. So
Okay, so
yeah, but definitely come chat with us afterwards. So myself, my colleague Rebecca, and Fabio in the back there, we are going to be around answering questions and love to talk more. Thank you.